Hello and welcome back. In this video we're going to be going over the slope formula. Now in the last video when we talked about determining the linear equation from a graph, or being able to go from graph to equation, we used the concepts of rise and run to be able to determine the slope. But some of you would probably like to have an actual direct formula that can be used to calculate the slope of a line. So before we go over that formula, we're going to go over a symbol that appears a lot in mathematics, and that symbol is the delta symbol. So delta means change. And I'll give you a straightforward example here. Delta apple would mean change in number of apples. And so the formula is always the final amount minus the initial amount. So in this case, delta apple is the final amount of apples, or apple F, minus the initial amount of apples, or apple I. So let's say, for example, that your initial amount of apples, or apple I, was 3. So you went into a store with 3 apples. And your final amount of apples was 5. So apple F is 5, you came out of the store with 5 apples. If we plug that into the formula, we would have that delta apple is 5 minus 3, or 2. In other words, we would have that the change in number of apples is 2. Or the number of apples that we had increased by 2. Which makes sense. We had 3 apples and then we had 5 apples. So we must have gained 2 apples. So that is the concept of delta. That triangle symbol is the delta symbol, and it means change. So the reason why I introduced it in this video is because it is involved in our formula for slope. So the formula for slope is m is equal to delta y over delta x. And once again, we have final minus initial. So delta y is final y minus initial y, and delta x is final x minus initial x. So I'm going to start off with an example over here. Let's say we had a line and we wanted to find the slope of that line. We would pick any 2 points on that line and write down the initial and final point. So in this case we can say that the initial point is 0, 2, and that the final point is 1, 4. So therefore x initial, or xi, is 0, and y initial, or yi, is 2. Similarly, for the final point 1, 4, x final, or xf, is 1, and y final, or yf, is 4. Plugging that back into the formula, we have that delta y is 4 minus 2, and delta x is 1 minus 0. In which case we'll have 2 over 1, or 2, and therefore the slope is 2. And now what I'm going to do is put some color coding in case it helps you better understand how we plugged in the numbers into the formula. So once again, we did the y final minus y initial, and x final minus x initial. And that gave us that the slope of this line was 2. So a lot of you have the question, how do we know which point is initial and which point is final? And the answer is it doesn't matter. So we picked the initial point to be 0, 2, and the final point to be 1, 4. But I could have easily done it the other way around. I could have picked the initial point to be 1, 4, and the final point to be 0, 2. In that case, you'd have that x initial, or xi, is 1, and y initial, or yi, is 4, and x final, or xf, is 0, and y final, or yf, is 2. Once again, I could just plug that directly into the formula. I'd have that yf minus yi is 2 minus 4, and xf minus xi is 0 minus 1. In which case I'd have negative 2 over negative 1. And we know that a negative number divided by a negative number is always positive, so we'd have 2. And notice that this is the exact same result we got before. The slope is 2. So it doesn't matter which point you pick to be initial and which point you pick to be final. It will always give you the same slope. And if we wanted to, we can then find the equation of this line. We just established that the slope of this line is 2, looking at the graph, we also see that it intercepts the y-axis at the point 0, 2. That means that b is equal to 2, and we have that y is 2x plus 2. So I'm going to do another example. So this is going to be the same idea. We're going to pick any 2 points on the line. So in this case, we'll say that our initial point is 0, negative 1, and our final point is negative 3, 2. Once again, it doesn't matter which point we pick to be initial and which point we pick to be final. So for the initial point, we have that xi is 0 and yi is negative 1. And for the final point, we have that xf is negative 3 and yf is 2. And once again, we could just plug that directly into the formula. We would have that yf minus yi is 2 minus negative 1, and xf minus xi is negative 3 minus 0. So that would give us 2 plus 1, or 3, over negative 3. And that is negative 1. So we've established the slope is negative 1. Again, we can look at the y-intercept and note that the y-intercept is 0, negative 1. Therefore, b is equal to negative 1. And we have that since m is negative 1 and b is negative 1, the equation for the line is y is equal to negative x minus 1. And that would be the equation of the line. Once again, I'll put the color coding if it helps you better understand how you plug the numbers into the formula. So that's all I wanted to go over in this video. As always, thanks for watching.